4.1, number 12. Here we want to solve the system by graphing, just like the last two problems we did. And I couldn't figure out how to get rid of the feedback, so sorry about the funky noise we got going here, but hopefully it works out okay. So first we have x equals minus y, and then x plus y equals 7. And as usual, we're going to find points to graph for each one of these. And we can pick whatever we want to plug in for x and y. I think for this first one, I'm going to put in x as 0 first and see what I get. If I put x as 0, I get 0 equals negative y, or y equals 0. So the intercept, x and y intercepts are the same here. 0, 0 would be both of them. So I do need to find another point in addition to that. So I'll just put in, I don't know, how about y equals 2? Because if I put in y equals 2, the equation works out pretty easily to be x equals negative 2. So I just plug in y equals 2, and there I go. Out pops out my x. So now I've got 2 points for that one. Let's move to the next equation. I have x and y on the same side, so I'm going to go ahead and find the two intercepts. Put x as 0, and x as 0 means the first term goes away, and we get y equals 7. So the y-intercept is at 0, 7. Then I'll put y as 0. Y is 0 gives me x equals 7. And that's the x-intercept. So now I have enough information to do the graph. And as always, do a third point if you are doing a test or something. Make sure that your points are all lining up into a straight line. So let's see if these two lines are intersecting lines that give us a solution. For the first equation, we have 0, 0 is our first point, and minus 2, 2. Minus 2, 2 is our next point. And draw a line through those. And that's our first line. The second equation, we have 0, 7. So 0, 1, 2, 3, 4, 5, 6, 7. So it's right up here where I wrote my y. And 7, 0. 1, 2, 3, 4, 5, 6, 7, 0. Let's make another line here. And it looks like these two equations are parallel, or pretty close to it. It's hard to say sometimes because if you make a graph by hand, it might not come out perfect, and then it might not be absolutely positive that these are parallel lines. So we have no solution. One thing you can do to check is parallel lines should have the exact same slope, and they should have different y-intercepts. Now if you remember from the slope-intercept form of the equation, y equals mx plus b. Alright, same slope would mean the m values are the same. Different y-intercepts would mean the b values are different. So what you can do is solve each of the equations and put it into the mx plus b form. So let's go ahead and do that and double check to see that we get the same slope with different intercepts. First equation was x equals minus y. If I solve for y, multiply both sides by minus 1, clears away the minus sign that's with the y, and I get y equals negative x. I have a slope of minus 1, and my b value, there's nothing here, right? I have plus 0 basically. And let's check the other equation. X plus y equals 7. Solve for y means take away x on both sides. If I take away x on both sides, I have y equals minus x plus 7. Slope is the coefficient of x, so it's minus 1, which is just like the other slope. And the y-intercept value is given by this b here, so these are different. Same slope, different b's, parallel lines. So that's one way to check to see if you really do have a no solution.